Okay, I just want to take a little look at the concept of disproportionation. This is something that you will definitely see on the diploma exam. It's a term that they like to throw in there, and it's a concept that you should be quite familiar with, leading into that diploma exam. Now, it is a very complex word for a relatively simple concept. So let's just take a look at what disproportionation means. Just as a reminder, disproportionation is when an entity is both oxidized and reduced in a redox reaction. So one entity as a reactant is both oxidized and reduced, or it gains and loses electrons in a reaction. Now, there's both an increase and a decrease in our oxidation number. So you'll have to remember some of the rules when we assign oxidation numbers from our previous little lesson there as we go through some examples of disproportionation. Let's take a look at our first example. When we assign oxidation numbers here, I'm just going to make sure I have a good pen here. I know oxygen has an oxidation number of -2, which means I have a -2 charge here, which means that copper has to be a +1. +1 times 2 is +2, cancels out my -2. -2 and +1 for oxygen, then hydrogen. Copper here is 0. Then I have -2, and I must have a +2 here. And then I have a -2 and a +1. When I look at the entities that have changed oxidation number, I see that copper goes from +1 to 0, as well as copper goes from +1 to +2. So when I look at this chemical reaction, I see that copper here in my bottom arrow goes from +1 to 0, which means it became more negative, or it gained electrons, or it was reduced. Okay, more negative, reduced. And in my top arrow here, I see that it became more positive. Okay, more positive means it's losing electrons or is being oxidized. So when I see where one entity, such as my copper here, my copper is both reduced and oxidized all in the same reaction, this is called a disproportionation reaction. Okay, let's take a look at the second example here. Again, oxygen -2, chlorine must be -1 in this example. Okay, +1 in this example because I needed a net negative charge of -1. Okay, chlorine is 0 here. I have -2 times 3 is -6. I need a +5 to get a net charge of -1. Again, I see that it is goes from +1 to 0, as well as it goes from +1 to +5. +1 to 0, it became more negative, it gained electrons or got reduced. And +1 to +5, it actually became more positive. More positive means it's losing electrons. In other words, if it's losing electrons, it is being oxidized. Okay, let's take a look at our last example here. We see that we have hydrogen peroxide and water and oxygen. Now we have, I'm going to start on this side, -2, +1, and 0. Now don't forget in your example here, when we see oxygen in peroxides, we have a -1 charge. So we have -1 times 2 and +1 times 2, and this is where we see a little difference in example. And so again, we have a -1 to a -2, becoming more more negative. Again, it's gaining electrons. If it's gaining electrons, it's being reduced. And here we see it goes from -1 to 0. It's becoming more positive. It's losing electrons or being oxidized. So that is essentially what disproportionation is you have only one entity changing in your reaction, and that entity is both oxidized and reduced. Now you may see these examples come up either in my practice questions or on the diploma, so be very familiar with the concept of disproportionation. Now if you need some more help, there's plenty of videos on YouTube that you can go and check out, or you can check out some of the pages in the textbook if you would prefer that as well. Okay, good luck!